In today's video, we will see binary phase shift keying, or in short BPSK. Sometimes it is also called only PSK, that is phase shift keying. So if they will ask in the exam phase shift keying or binary phase shift keying, both are same. Binary means bit 0 and bit 1, and phase shift keying we are basically using only 2 bits, that is 0 and 1, so both are same. First we will see how binary phase shift keying work. First we will see the transmitting part of this. So the transmitter is having a phase modulator. You must have studied the phase modulation in analog communication. In phase modulation, you have a phase modulator. From one input you are giving the carrier signal A cos omega ct, and from the other input you are giving the modulating signal f of t. So instead of f of t, you are here giving the bit sequence, that is the binary data which you want to transmit. So instead of ft, you are using bt. So from one input you are giving the bit sequence, from another input you are giving the carrier signal. The output of this phase modulator is nothing but the binary phase shift key output. So mathematically, how you can represent this BPSK signal? It is A cos omega ct plus phi, where phi is equals to 0 for bit 1, and phi is equal to pi for bit 0. So when phi is 0, your signal is A cos omega ct, and when your bit is 0, your signal is A cos omega ct plus pi. 180 plus theta will become minus theta. So that is why generalized way you can write your BPSK signal as plus minus A cos omega ct. Plus represent bit 1 and minus represent bit 0. So when you transmit bit 1, basically you are transmitting A cos omega ct, and when you are transmitting bit 0, you are transmitting minus A cos omega ct. Now the bit waveform of this signal, suppose here I have used bipolar transition. This is bit 1, this is bit 0, 1, 1, 0, and this is your carrier signal. So what will happen when there is a transition from bit 1 to bit 0? You will have a 180 degree phase shift. Like your signal is something like this: 1 to 0, 180 degree phase shift. Again 0 to 1, 180 degree phase shift. Again 180 degree phase shift. So this way you can see here, here and here you are having 180 degree phase shift. So this way you can represent your BPSK waveform. So now we will understand the concept of BPSK receiver, how BPSK receiver works. So this is a BPSK receiver circuit. This is the BPSK signal given to this square law device. Let us say either you will get a BPSK signal as A cos omega ct or minus A cos omega ct. Let us say your signal is A cos omega ct. It will be given to this square law device. The square law device will square the input. So output of this square law device will be A cos square omega ct. This A cos square omega ct can be written as 1 plus cos 2 omega ct by 2 from the trigonometric relationship. This band pass filter is set at 2 omega c frequency. So what it will do, it will remove the A by 2 component and it will pass the A by 2 cos 2 omega ct component to the next block. This next block is a frequency divider which will divide the frequency by 2. Suppose you are giving a 200 Hz frequency, the output of frequency divider will be 100 Hz. So basically it will divide the frequency into half. So A by 2 cos omega 2 omega ct will be passed through this frequency divider and you will get A by 2 cos omega ct. So basically from these three blocks, what you are doing, you are basically extracting your carrier from the BPSK signal itself. That is why these three blocks are known as carrier recovery circuit. From here you are recovering the carrier from the modulated signal. Then this modulated signal, BPSK signal, is given to this multiplier. So the signal is A cos omega ct, and then A cos omega ct comes from here itself. So it will be A cos square omega ct. It will be passed through the low pass filter. Again, this A cos omega ct can be written as A by 2 plus A by 2 cos 2 omega ct, same way like this. So when it is passed through a low pass filter, this low pass filter removes the frequency above omega c. So this part will be removed from the low pass filter and you will get the output as A by 2. So if A by 2 you will receive, that means which bit you are receiving? Bit 1 you are receiving. Likewise, if suppose the signal is, incoming signal is minus A cos omega ct, it will be given to the square law device. The square law device will give the output as cos square omega ct, because even if it is negative, the square will be always positive. It will be given to the low pass filter. It will pass the 2 omega c component. Then it is passed to the frequency divider. So that means carrier will recover from minus A cos omega ct as well. Then this minus A cos omega ct will be given to this multiplier and it will be multiplied with cos omega ct. So it will be minus A cos square omega ct. It will be minus A by 2, and this minus. Again, when it is passed through the low pass filter, this component will be removed and you will get minus A by 2. Right? So when you will get plus A by 2, bit 1 is received, and when you will get minus A by 2, bit 0 is received. So this is how you will receive bit 0 and bit 1, or you can say in other words, you will receive the whole bit sequence which you have transmitted from the transmitter. This is how your BPSK receiver works. This is somewhat complex circuitry as compared to ASK, but the carrier is recovered from this circuit itself, that is the carrier is extracted from the circuits. So you can say this waveform or this phenomena is better than ASK. So BPSK gives the better result as compared to ASK signal.